Constraint Application Protocol. CoAP stands for Constraint Application Protocol, is an application layer protocol designed for low-resource devices and IoT. Inside the CoAP system, nodes can follow the client-server paradigm. And when interaction outside of the CoAP environment is needed, a REST CoAP proxy handles the conversion of requests and responses. Here are some of the important features provided by CoAP. Resource observation, which is on-demand subscriptions to monitor resources of interest using publish-subscribe mechanism. Blockwise resource transport is the ability to exchange transceiver data between the client and the server without the need to update the whole data to reduce the communication overhead. Resource discovery, that is, server utilizes well-known URI paths to provide resource discovery for the client. Interacting with HTTP, flexibility of communicating with several devices because the common REST architecture enables CoAP to interact easily with HTTP through a proxy. Security, CoAP is a secure protocol since it is built on top of Datagram Transport Layer Security or DTLS to guarantee integrity and confidentiality of exchange messages. MQTT is a standard messaging protocol for the Internet of Things. It is designed as an extremely lightweight publish-subscribe messaging transport that is ideal for connecting remote devices with a small code footprint and minimal network bandwidth. MQTT today is used in a wide variety of industries such as automotive, manufacturing, telecommunications, oil and gas, etc. The MQTT protocol defines two types of network entities, a message broker and a number of clients. An MQTT broker is a server that receives all messages from the clients and then routes the messages to the appropriate destination clients. An MQTT client is any device from a microcontroller up to a fully fledged server that runs an MQTT library and connects to an MQTT broker over a network. Three major specifications exist for MQTT. MQTT version 3.1, this specification covers three main sections: the message format that is common to all packet types, the specific details of each packet type, and how the packets flow between client and server. MQTT version 5 adds several new features to MQTT version 3.1, such as enhancement for scalability and large-scale systems, improved error reporting, and performance improvements. MQTT-SN is designed to be as close as possible to MQTT, but is adapted to the specific characteristics of a wireless communication environment, such as low bandwidth, high link failure, short message lengths, etc. It is also optimized for the implementation on low-cost battery-operated devices with limited processing and storage resources. XMPP is a set of open technologies for instant messaging, presence, multi-party chat, voice and video calls, collaboration, lightweight middleware, content syndication, and generalized routing of XML data. The architecture of the XMPP network is similar to email. Anyone can run their own XMPP server and there is no central master server. This federated open system approach allows users to interoperate with others on any server using a JID user account, similar to an email address. The Advanced Message Queuing Protocol is an open standard application layer protocol for message-oriented middleware. AMQP is based on message transportation, queuing, routing, including point-to-point and publish and subscribe, reliability, and security. Communications are handled in a broker by two main components, namely exchanges and message queues. Exchanges direct the messages to queues, and queues store the messages to be sent to subscribers. HTTP. Hypertext Transfer Protocol is one of the most used protocols on the Internet and has formed the foundation of data communication over the World Wide Web. Communication between client computers and a web server is done by sending HTTP requests and receiving HTTP responses. Communication between clients and servers is done by requests and responses. A client, such as a browser, sends an HTTP request to the server. The server receives the request. The server runs an application to process the request. The server returns an HTTP response or output to the browser, and the client or the browser receives the response.